up on the screen. We
50
have
ways to lose your power.
active voltage supply relay terminal 30 implausible signal and manifold absolute pressure or bar pressure range performance. So those are the two active. Those are the two codes that are on. And I think Noah, tell us what you've done so far, and we've gotten little success.
So I brought the car in, pulled the codes, and then popped the hood. And right when I popped the hood, there's a wire on the that goes to that map sensor that was chafing on the power steering pump. And so I ended up repairing that wire and then reset everything, drove the car, and the check engine light comes right back on. Code's still there.
Okay, same fault?
Same code, yeah.
And that's the barometric pressure fault?
Yeah.
Okay.
Yeah, you cleared it, comes right back.
Okay, yeah, there's not going to be an adaptation for that because it's a live signal. So you guys may be able to remember way back at the very first episode. This is where we get the and besides boring you with a bunch of jargon, one of the quick tests that I threw out there that I said, "Oh, this is going to help you." Anyone remember that?
What is it?
One of the quick
on engine off.
Yeah, the quick test that I told you that is kind of an imperative, nice little quick shortcut, answers a lot of questions.
I did that too today.
Perfect, nice. What was that test?
It was here. I could even pull it up right now. It's
nice. Here. So we'll look at you're on the Autel?
Yeah, I'm on the Autel right now.
Perfect. So we'll look at that.
Was down right. Where'd it go? There it is. This one and this one.
Hold on, we got Jack's doing some technical stuff real quick.
Yeah, he's gonna probably throw up the Autel screen. Yeah. Oh, sorry. You know what? Hey Nico, did I jump in too early? Because I'm kind of like that.
No. You know what we could do? Let's just go over this.
Just get an overview.
Yeah, hold on. We're having a little bit of a technical problem here that maybe we have a bad cable because that speaker was working. We could go over this 97 M3 too. So we got two cars here today.
Okay.
We have a 97 M3. This is this car, like a couple months ago, we put in a used DME because it was not firing the cylinder 5 ignition coil. So we put coils and a DME in it. The coil was melted on cylinder 5. So we put coils and a DME in it. Shortly after that, the check engine light keeps coming on, and it has this throttle position sensor code plus the other code for the idle valve that came on. Throttle valve potentiometer, 1B idle actuator closing winding, and 35 idle actuator opening winding. So what we did is we oscilloscope the throttle position sensor, and what might be kind of worth noting here is that for a couple of years now, this car has had a funky complaint of every once in a while when you start it in the morning, it won't take the throttle and it'll stall out. And then after 30 seconds, it finally takes the throttle and the car drives off. This is the same one. We put the air mass speeder in it from last week or 2 weeks ago.
Yeah.
And it seems that we have corrected I have not checked the fuel trim since the last drive, but So after we got the code for the TPS, we're just kind of going after this TPS problem.
Right.
That's on the 97 M3.
And those are DME faults, right?
Those are DME faults, correct?
Okay. Because you had one in the DSC as well, correct?
Yeah, there's also DSC faults, and they come on. So what happens is so I drove this car 80 miles over the weekend. The ASC light goes on and off maybe 3 or 4 times. And then finally at the last mile, like at mile marker 80, the check engine light went on. When the DSC light goes on, it flags both front wheel speed sensors faulty. It flags, I have to go look up Moon's ticket, but it's all in there. It's throttle valve, throttle valve potentiometers, all that. And then in the DME, there's only those 3 codes.
Yeah, and so we were thinking that the ASC was throwing the fault because of the additional throttle on top, but it may actually be input from the engine throttle, right? For torque limitation and input. If it's missing that input, it's not going to start slamming its own throttle.
Yeah, that's what we
Yeah.
think.
I thought it was faulting the additional throttle, but it might actually be faulting because of the engine throttle. Now that we see that we have a fault for the throttle, like in the DME, because we didn't have one in the DME before, right?
We didn't have I don't know if we didn't have one in the DME before.
Okay.
Before we did.
There was.
Okay. Alex says there's always a potentiometer code in the DME.
Okay. All right.
So we oscilloscope the TPS, which I shared that with you.
Yeah, I'll pull that up right here.
And the only thing that can you plug this guy in, please?
Oh yeah, the Pico.
Yeah. So are you on the Pico?
Yeah, I am.
Oh, okay, perfect. Here, let's go I'll open it for you. We'll go into here and the battery may have just taken a crap.
Yeah.
Yeah, just turn the computer off.
It's one of those days.
Okay. You got to plug it in, Alex. You got to do it. Just plug it. Yeah, there you go. There it is. Oh, yeah. You got power. All right. Wait till that boots up. So anyways, we got the Autel. So we could jump back. So that's that car. So we could jump back to the the Volkswagen real quick.
Okay.
They are different by 10 millibar.
Okay.
No, oh, look, it's switching right now.
So your key on, engine off, you're comparing the ambient pressure to the charge pressure, right? And
yes.
And you're seeing it.
Jax can pull that. Hey, Jax, put that Autel back on the screen. That way Eric can see it. Because right now what's happening is very slowly it's changing in the scan tool data. It's going from 989 to 999.
Okay, so 989.
It's air pressure. The map is the G71, which is that's the one that you repaired the wires on. Yeah. So
that's a tenth.
Is this like just ambient air pressure?
That the other one is ambient. Yeah, that's inside the computer.
So 10 millibar.
Uh-huh.
I went ahead and cut it, and then I put in this wire and just used 2 butt connectors. And
Hmm. Okay.
I mean, I taped it up and zip tied it just so it wouldn't get caught. Right on there.
Okay. Because if that was cutting through, that would certainly be a reason why our map sensor circuit would be out of range.
Okay.
And if we still have a problem, I would suspect the repair.
Okay. So,
Right.
what would be the proper way to repair this thing?
Well, you're off by 10 millibar here, which really that's on the upper, and it's bouncing back and forth. So
I guess the question is, why is it bouncing back and forth?
there's some kind of voltage fluctuation there, whether it's the ground or the repair or the sensor itself. So you're going to have a 5-volt reference coming in, so you'd want to check that. And which wire did you repair? Do you know?
We're gonna cut it open right now and find out.
Okay, yeah. If it's the 5-volt or if it's the signal or what. And this, 10 millibar though. I mean, if it was off by 10 millibar, I'd be a little suspicious, but I couldn't say that would be the root cause of the fault. Now the switching might be, that, but that value is pretty small to make an implausible signal fault. With it unplugged or disconnected, I'm sure it was, for certain there was a plausibility issue. And so, I mean, but besides that, are you seeing anything else? It was just the charge pressure fault, plausibility, and what was the first fault?
Terminal 30.
Terminal 30.
Terminal 30 relay. Where
Okay.
was the other wire? So right now I'm looking at the wire. Where was the other wire that was partially chafed that you
It was
did not
this one.
repair?
Well, no, I'm wondering if there was another one that was partially chafed, but I don't see one because these.
So
three
this
wires,
is four. So this is 4 wires inside this harness.
Yeah, which these wires they would have it. It would be like right here because that's where this one was. It was like right about here
Okay.
where they were messed with or cut through. And these ones don't have any sign of being cut through.
Okay. So then I guess it would boil down to, did we get a good connection on this stuff? So then you kind of pull it, and then these are melted. That's melted on there. Hold
Yeah.
on,
I heated those up to heat shrink it.
so then pull on like that. Yeah, I mean they're on there tight. They're not coming
pretty
out.
solid connection.
So we have a voltage that is varying.
Is it the voltage or?
Well, we have a scan tool data that is varying.
Yeah. And then the terminal 30 relay. If we just think about that, so that's going to be an on signal, what we might call a KL15 relay on the BMW side, I think, because it's going to be switching B plus power, when the ignition is active or in the accessory position. I'm assuming that's what that would mean, and is it a KL30 relay plausibility or what?
What does it say? Go back. It says voltage supply relay terminal 30 implausible signal.
Okay, implausible signal. All right. So either the alternator is putting out more than the terminal 30 output, the relay output, or usually that's what happens. So there could be either a voltage drop at the relay, across the relay, out of the, somewhere after the relay. you know,
We have to
that's
find out where the relay even.
or what if there's anything easily accessible that runs off of that power from that relay. The fuse block is probably the easiest place to start, because I'm sure that terminal 30 relay provides power to a certain section of fuses.
Yes, yes, yes. And this has that faint, like the infamous Volkswagen fuse block that's on top of the battery that always melts. But this one looks like it's in pretty good shape. It's got the 4 like strip fuses that are like bolted down with 6mm nuts.
Okay.
And then it has 3 little 30 amp fuses, and they all appear to be good by looking at them.
Yeah, I would do a voltage test across them.
We could test we could test all those fuses real quick just to make sure.
Yeah, and then but that's kind of without getting just on the surface of the verbiage of the fault code. I would imagine that implausible output or implausible signal is from, you know, low voltage supply voltage to a certain circuit that, you know, lower than what the alternator is outputting. And now you didn't get any over voltage faults, but that would be the other thing to wonder, like, is the alternator putting out too much voltage? But usually it'll fault for that, you know, because 16 volts is the threshold for that. So I think you've got something with a block of fuses. And since the engine control module is the one that's setting the fault, it's probably related to that block of fuses, whichever supplies the engine module.
Okay, now should we, because our scan tool data is fluctuating, should we maybe oscilloscope this sensor harness that we repaired?
Yeah, it's pretty easy to. You can grab the power and ground, you know, with one probe, and just see. We should have 5 volts coming into that, I'm pretty certain, and then you're going to have an output, which will be for the charge pressure, and then there may be another. You say you got 4 wires in there. Maybe there's a second output. Which
Is there all 4 go to that one sensor, or does the harness break off into another harness somewhere? So all 4 go into one sensor. Where's the
That's
sensor?
Right there.
That one.
Yeah.
Okay.
so
What
4
does-
wires.
Oh wait. No, that's the other one.
What you
That's
talk-
this one
What you talking about?
right here. This is our same.
I can't see anything.
Okay. This is
What
a
do you-
separate harness. The one with the 2 wires splitting off. That's going to the washer pump.
Okay.
Oh, do you have the washer pump? Here, squeeze the washer pump. Does your charge pressure change?
Yeah. So that's what it looks like it's going to do.
That's the
Okay.
boost.
So, yeah,
Charge
that's
pressure.
good.
It's the tuning hack. You hit the washers and you get extra boost.
Okay, so we can do. Okay, why don't you pull up a schematic for that in
Okay.
all data,
Okay.
and then we can see which wire does what color does what. Then we can do it. In the meantime, we can jump back and forth between cars. We have the M3 and it's on right now. Did you get booted out of? Are you on this computer still or no?
No, I got the clown shoes, so I can jump back in there. I think. Let me find my mouse. Where's that? All right. All right. Okay. Should. Okay, so you're gonna have a different UltraViewer password.
Ultra Viewer. Let's see. I might need Jax's help.
Oh, it should just be a little icon in the lower tray.
Lower tray.
Yeah,
Ultra
it's
Viewer.
yeah, the little blue circle with it's like a little picture of a computer, but half blue, half white.
Like the
Hey,
Microsoft
Eric, I
Edge?
sent you the code for that computer.
Is it? But if it restarted, it'll change the code.
It shouldn't have restarted. I don't think we restarted the computer.
I think the computer turned off.
Oh, Then let's do it again.
Hey, Jax, are you preparing for winter? Is this your fall look?
Yep. This is Jax's summer look.
No. Summer look a lot less hairy.
Okay, I got you. You want the ID and password?
The ID should be the same 715-411-22. And
Yes.
then your all right. What's your password?
34578.
There it is. Okay, got it. Let me get it. Okay, I'm gonna pull that over here. Make that big. All right. This car is just on right now, right? There's no
Keys on.
engines off.
Engine's off. And then the other thing is, what was clicking underneath the throttle body that we disconnected yesterday? The evap purge valve was like clicking. So
Mhm.
then we thought maybe that was interfering with all this. So then we disconnected it, didn't do anything. So then this car, just to note, this car has a big giant boombox in the back. The rest of the car is very
that's
stock.
right. Right, you
But-
told me about that.
It's got like a 10-inch subwoofer mounted to the floor. And the DME, we thought maybe it was the used DME, but we swapped the used DME back into it, and it had the same thing.
Okay. When I was looking at your so the green trace is you're telling me the green trace is the throttle potentiometer
And
signal.
here I can move it. Yes, and see, look, I'm moving it right now.
Yeah, and was that a smooth movement, or are you like, if you just give me a straight wide open throttle
Straight wide open throttle.
right now?
All right, that's it.
Okay, let's pause. Oh shoot, I lost it. All right, let's go back here. All right, I'm gonna share my screen real quick. Share screen, and we're gonna go. Yeah, I got it. Okay, which screen am I sharing? I don't know. Come on, man. We are going to Windows.
I think so, because it's
All right.
got 4 wires.
All right, you guys seeing that? Am I sharing that? I am. Okay, now I'm sharing it. Let's make this big.
Yellow.
Nope. Let's make it big. Make it big. All right. First of all, look at this. This is kind of interesting. Your ground starts at what, 750 millivolts off of 0. So that's certainly an elevated ground. That's
But isn't that where it's supposed to start?
750 millivolts. That's, I would say, under 500 millivolts, right? If it's a floating ground or a DME controlled ground, 250, 500 is kind of high. 750 is.
But that's straight. That's just straight the signal, though. Like between 750 and then what's the high side on that green line?
Let's see.
That's where it's supposed to operate in, right? Like between 750 and 4.5 volts.
I would say no more than a half a volt. But so 433 ish. All right, hold on. And that was wide open throttle.
Yeah, that was wide open. We could do
No.
this.
Here. Let's do this. So this should add up to 5 volts. And it's more than 5 volts. Right?
Oh,
So these-
4.4 plus 0.7.
Yeah.
Oh, okay. All right.
Yeah. And so you've got a little bit more than that.
I will say this, that ground, I'm not calling it the ground. I'm calling it the bottom of the signal, right?
Mhm.
That
Yeah.
number kind of fluctuated yesterday. It was like,
Yeah. It looked
yesterday
like
was
you had
0.
800 at some point.
Well, that was we were barely lifting it off idle, but it was also at 0.668. Like I think before that it was even a little bit lower than that, like 0.64. We're talking about hundredths of a volt now.
And this is the sensor that's right on top of the throttle, right?
Yes, right on top of the throttle. And right now, so we measured it in 2 places, just thinking that maybe the harness was causing this. So
Mhm.
currently right now it's at the DME, pinned out at the DME. The 5-volt
Okay.
reference, the ground, and the signal are all we're back probed into the DME.
Okay. So here's the spec. You're right. It's approximately 0.6 volts to 4.2 volts at full throttle. So that is correct. So I'm getting that from right there. So I don't know if you can see that.
So the question that I had was, what are all those spikes, and do we need to worry about them or not?
Well, that was kind of what I was wondering. And when I saw your 0.8 volt signal floor with the trace you sent me from yesterday, I was, and you said you had a melted.
The 0.8 may have been us just barely giving it throttle. Right. So we were like, because what we were looking for, like a dropout, right? So then we were just like barely giving it throttle and then kind of like just waiting in that range to see if the thing would like start going crazy, but it never really did. It just kind of stuck at 0.8.
Okay.
If you go back before the 0.8, does it go lower than that?
No.
I think it might go down to 0.6.
Hold on a second. Let me look. I didn't see that. I went back, it had like 18 frames, and I went back, and it was pretty solid all the way across, and then you did a couple of sweeps.
Okay. Let's see. I can open it. The one from yesterday. Here it is from yesterday. So, okay, there's our 0.66 currently.
Okay. All right.
And then if I go back, if I go to the beginning, at the beginning, I think somewhere is where we kind of just barely gave it throttle. Maybe we just kind of, so it's at 0.66 right now.
Oh.
Yeah.
Okay, hold on. What did it do? What did it do? I don't know what happened there. Oh, let's stop that. All right. Okay, so 0.66 is your ground, but if you're looking at the signal, which is the red trace. Let's see.
No, 0.66. No, not the ground. Look on the right side.
Yeah. Okay, I see. Yeah. All right. And so what happened here? We go. Yeah. All right. Yeah. Okay. 0.66, and then let's see here. Let me just see. We have so that puts it at 4.7 ish total. There's not even about 4.6. Yeah. All right.
But then we got to ask Daniel if he did full throttle yesterday or not. So Daniel was the one sweeping this one yesterday, and he said he didn't go to full throttle.
Okay. Daniel, my brother, you want wide open throttle for me? Okay. Right, let's go back to our live. We're live here. Live Saturday night. Because I had paused it, so we'll go back and.
I think you just just hit play. There you go.
All right, so what do we got here? We got these hash marks, and what I was just thinking is that we've got those idle control valve faults, right? And so I'd sent you the detail, which we've got idle valve information here, but this is not the one that gives me the frequency. So the DME is grounding. It's providing the ground to both coils, right? And then so it's switching the coils for the idle control valve conversely. So adjusting the duty cycle, but it's a fixed frequency, which is a value that most people don't pay attention to, and they didn't have it in the MS41, but it's going to be over here. To see if you have an issue with the DME itself, the duty cycle is going to be changing, but the frequency, if the frequency is off, then that's only an output of the DME. So it was a value that was kind of just a nice quick check for, do you have a problem with the DME on that circuit? Where is it at here? All right. I'm trying to remember where the heck I have that. Thought it was in the book. I thought I made a big note of it. But I do have that value because it's every time I want to find it, I can't. It takes me a while. So that brought me back to the ground issue. And if it's having a problem with the coil, both the open and the closed coil, do we have a problem with the ground? Right? Is it not switching the ground? Which also kind of, when I thought I saw in the signal you sent me, it was 0.8, signal floor, and I'm thinking, man, this sure looks like we've got a ground issue. And then I started thinking about the melted coil, like, because that the 4A circuit for the coil measured to ground there should be 235,000 ohms, I think is what that's going to be in here too. But just to make sure that 235 ohms, sorry. But the ground, and then what is this? There's something being induced. This is obviously, if we look at it, there's an inductor, so that means there's a winding. Something with a winding that is inducing some voltage into this. So let's just zoom in on this. Let's take a look and see what we can glean from this. But yeah, this is not that great. I mean, how big is this this little blip? It's probably half a volt itself, right? Let's see.
Yeah, and I haven't measured it, and it's it's a very intermittent code. It'll take 80 miles worth of driving for the check engine light to come on, but the ASC light will come on much sooner. The ASC light will come on I went from Leucadia to Loma Santa Fe, and I saw it at like Loma Santa Fe, the ASC light was going on. And then I looked down again, and then the ASC light's off.
Hold on. I know. My dog doesn't like that. It's like, hey. That's enough. I understand. We get it. Okay, cool. Thank you. Hey, leave it. We're focusing on the DME, buddy, not the ASC. Sorry. He gets excited about that. That's Dexter, the diagnostic dog. He's all about, like, what is... All right. So... Well, this is completely different from what I was expecting to see. I thought there would be a ringing, like but that's not what we see here. But peak technically peak to peak is somewhere about a volt, but it's not actually ever a volt. So we've got about what's that? So it's the lower peak. So this is interesting. This is not what is it doing now.
But look at the actual 5-volt signal actually goes up a touch.
Oh man, here we go. Let's see. Yeah. We are getting little squiggles, but so they're little peaks and then ring, peak and ring, peak and ring. Positive and negative. That's so in 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 10-ish. That's interesting. What would do that? And you said you had a clicking in from the purge valve.
The evap purge was just clicking away. It doesn't ever, like, key on, engine off. The purge valve like never turns off on this car. It just always is on. It's always clicking. So we disconnected it in hopes to change this, and it didn't. It just stayed the same. Now we didn't look at it that close, so I don't know if it actually stayed the same, but it didn't go away.
Well, here this is it right now. Oh. We're way too zoomed in here.
Because the zoom's on. You can click the zoom off down there on that
trigger. Trigger. Oh no. And what channel is it? We're gonna get A and put it 80. 400. All right, that's good. And where's my trigger? And then turn the zoom off. Go on here. This. All right, so there it is. Now we can zoom in on that. Alrighty. Maybe a little more zoom. More cowbell. More cowbell. Oh, don't do that. Oh, that jacked it up. Go back. All right, I'm gonna move this guy over here. Move it. All right. So right now, we've got those codes for the idle valve, right?
Yeah.
Can you unplug the idle actuator?
Yeah. Let's do it. Here, Alex, you know how to do it. The idle valve's unplugged. You guys didn't say the idle valve was plugging. You guys said that.
Oh, yeah, that's gonna happen. Yeah, that should happen.
No, but you guys said that the other thing was humming. The purge valve. Yeah. Was humming. Okay. So, all right. So the IAC was humming and the purge valve was clicking. So they already unplugged both of them.
Oh, man. I think I'm drinking dirty dishwater. Okay.
Don't do that. So did you catch that? So we already have
the
IAC and the purge valve unplugged. That's why I won't idle right now.
Well, that's why we come together for these diagnostic solutions.
No, we actually haven't started it right just yet.
Felt
like we needed to put that in there.
Boom. What else? This is solenoids for Vanos. What else do we have? We have just trying to think of any kind of actuator on here. Anybody can jump in here with if they want to add an actuator to the list of possibilities.
Let's flash a light down in there. Down in here.
This does have the Vanos actuator, right? This is a dual Vanos?
No, single.
Single, okay. Oh, it was the Euro that had the dual Vanos for this engine, right? Okay,
Yeah,
so this is
I don't
still
even know.
single.
I don't even know. Where's the oil actuator on this thing?
It should be right on the intake manifold right there, right? Next to the oil filter housing.
See the cam? That's maybe, I see, is that the cam sensor? I see the cam sensor looking guy.
Solenoid. There's a there's a sensor down there.
Oh yeah. Oh duh. Yeah. No, it's right here.
Yeah.
But where's the electronic? Where's the electrical connector for it? Okay, it's hard. It looks like it's right there. It's hanging out.
Yeah, they're right there.
Yeah, put your hand on it. Do you feel anything happening there?
No, it's cold.
Okay. No little clicking or anything.
Yeah,
Oh!
click.
Wait a minute. Don't you have that the 3 two-way valve underneath the vehicle for the fuel bypass?
Uh-huh.
I wonder if that thing, because it hasn't started yet, right? So it's going to be activating that, because it activates it on cold start and then during misfire. But this thing is doing this all the time, right?
To yesterday when we were testing it, we only started it. I don't think we ran it since we drove it in yesterday. We haven't. It's just been off the whole time. Just key on stuff. So it's been cold.
Okay.
Why don't maybe we go in the trunk and see if something's like clicking in the trunk, like with the stereo.
I mean, you've got the amplitude. You know, when you zoom in, it's definitely a different picture from what we're seeing in the little groups of spikes that happen. But that amplitude is almost a volt, you know, of peak to peak, which is, I mean, I don't know how that couldn't affect the signal, and if the frequency is high enough, that it certainly seems like a possible issue with plausibility. And I'm wondering if we're seeing the same value, you know, the same induced interference on the idle circuit, you know, the idle control circuit coil, which could be the root cause of that whole plausibility fault, right? Again, that's a speculation. You've got the idle valve is I'm trying to think of words. Is it easily accessible? It's on the under, isn't it on the back side of the throttle under the intake?
Well, put it this way: you can't see the darn thing. It's like it's buried. We could backfeed it from the DME. That would be.
Oh yeah, back probe it.
Your back probe it. I mean.
Yeah. What? Let's see here. We could pull up.
But that could be. So what we could do is because we're coming up like on an hour right here.
Right.
What we could do is we could do some homework, and we could probe this Volkswagen Jetta.
I'd like to know what's going on with that, with the input.
To jump back over to that car, he pulled up the ALLDATA schematic, and there's what they're calling the N71 and a G72 and a G71 in the same sensor.
Okay.
Which one's intake air temp and the other is the map.
Perfect. Okay. Yeah. So the intake.
And the map is the color that where the wire was broken.
Is that the signal wire for the map?
I'm gonna try to. It's not. I don't know. I don't know how to read. I don't know how to read it. It's not giving me. Just pin 3 and 4, and pin 31 and 71, and it says T121, which that's the control unit, I'm guessing, or no, the connector. I don't know what's what. I don't know which
Okay.
is the signal.
Does it have any other designations next to it? To the wire?
The size is 0.35
Okay.
millimeter wire.
Does it have a letters? Any letters or?
Yeah, just the color GESW and LIRO.
Okay. All right. Okay. So that would explain the 4 wires. We've got temperature and pressure. So did we measure to see what the voltage, if we've got like a 5-volt coming in, and then what the voltage, maybe even the voltage on the wire that was repaired, what it's at?
We can do we can do that. We can just test the 2 wires with an oscilloscope. The 2 wires that we need are the green and black, the yellow and black. And then the other one is lilac and red.
Mm-hmm.
So we can test those 2 wires just to see what they are. And what you're saying, they're a 5-volt reference?
Yeah, I'm
5 volt.
I'm certain it's a 5-volt reference coming into that. It's and that can also be affected by other items on the 5-volt circuit, right? So if you have other devices or damaged harness, it can pull down, a portion or all of that leg of 5 volts, because it's usually broken up into groups of 5-volt output. But that one, I think the rail pressure sensor is a 5-volt. It might even be on the same circuit. What else is 5 volts in there? Oh man. Charge air temperature, which looks like it's combined, but if you have one on the intercooler, that'll also be 5 volts.
This is on the intercooler. It's
okay.
It's
on the intercooler.
That whole unit.
Okay, so there's not one on the intake manifold.
Let's see. Intake where's your light? Not one that jumps out.
Okay. All right. There's usually just one, but it's usually after the throttle. Right, because you'll have a charge air temp in an intercooler, right? Just to measure the boosted charge prior to hitting the intake, and then you might have a charge pressure in the intake manifold that also has a temp sensor, but usually there's almost always one on the manifold itself after the throttle, even though the throttle is open all the time, or should be, unless it's in emergency mode. So that's, we might want to do a little research on that, but I'd like to see what's going on with that. Make sure we have our full 5 volts, and is the voltage, the signal fluctuating, right?
Yeah, because the scan tool data definitely is.
Yeah, but it's 10 millibar, which is, I mean, it's not great, but it doesn't. I don't think it's not going to throw a plausibility fault, right? And remember how we talked about pressure sensors, how they fail. They don't have dropouts. They typically shift the whole range, right? The whole range shifts, and that's how it becomes implausible.
Yeah.
But it doesn't. I mean, 10 millibar is not ideal, but it's also, I wouldn't say that's a fault per se. But what's going on with that voltage? Do we have enough? Do we have a 5 volt reference that's fluctuating or low? We have a ground issue on that sensor. Is there other harness issues down the way? That's kind of where we want to look at that. And then, so what is it what was the freeze frame on that fault for the plausibility? No.
before you cleared it?
Well, the last fault after he road tested it, he said the mill came back on.
He's checking right now.
Oh, it's not showing it. It's not showing a freeze frame, is it?
No, it's not.
Okay, we might want to go to Global OBD2 and see what's showing up over there. And then on that terminal 30 relay, so that relay is going to be supplying a block of fuses, I'm sure. So we've got some kind of issue with the supply to that. Either the relay's output, a voltage drop across the contacts of the relay. So you can't start the M3, right?
Right now, not. We could plug everything back in and then maybe start it. Yeah.
No, I don't, because you're going to want to, if you're going to plug everything back in, I'd much rather you plug everything back in after you get your probes in place so that you can, so it's,
You mean for the IAC, you mean?
Yeah, I'd like to see what's going on there. And I will come up with the frequency that we're looking for.
Okay, so we'll back probe so we'll get it running and then back probe the IAC.
Yeah, and just I'd like to, even before you plug it in, it's obviously not what's causing these spikes, but any solenoid or anything that could be inducing this voltage should be. How about this? Do you see this voltage on if you just grab like the B plus on the back of the alternator and grab ground on the engine or ground on the chassis? Do you see the same induced voltage?
I don't know. We could try that. We could open channel D.
Yeah, that's pretty quick and easy. And then you got over to freeze frame. Okay, perfect. P0106. The P0106 is that that's the charge pressure manifold. Okay, cool. Right on.
So
All right.
plug that guy into the back of the alternator, like the big B plus in the back of the alternator. And then just bang down.
Calculated load 100%. Yeah, Noah, get it. 100% calculated load. It's a nice leisurely test drive around the block.
Yeah. Huh?
Oh man, it's set it with no vehicle speed. Intake temperature 26, coolant temperature 31. All right. What else? Let's scroll on down. Okay. So this is right on ignition on. Looks like. I mean, it's not. So it turned on the light while you were driving.
Oh yeah, no, good call. That thing's fucked up too. It's 12. It's got it on the 12 volt side too.
Okay. Oh,
Well,
that's more of what I was hoping to see, like a.
It's a bigger chunker.
Oh, dude, now we're talking. You got there's a capacitor in the back with that stupid fucking subwoofer I bet. It's just doing this.
Yeah. So I guess the question
on the subwoofer.
is it is it on the ground side or is it on the positive side? How do we?
No, that's induced voltage on the positive side. It should be cleaning it up, but instead it's actually discharging. That's crazy noise.
Maybe we can disconnect the
yeah,
unplug the amplifier.
yeah, or that box in any related component. You know, just take the power away from it.
Let's watch it live. Where's your flashlight? All right, you guys watch. You guys see what's happening over here? Yeah. All right, you start unplugging the back. Come over here.
So the difference from the body to the engine is that it's got a little filtered. So we're just getting the peaks.
Okay, let's see what we got.
This is definitely coming from the body side of it.
So we can disconnect the big ass 0 gauge speaker wire.
The 0 gauge power supply.
What's this right? Hold on. There's a big. You know what? What's this right here?
Ow!
Press. So I just opened it. Is it still there?
Yeah, it's still there.
So there's just a big ass amp, or like a 200 amp circuit breaker. I think I just turned it off, but I don't know if I did or not. Let's disconnect the. That's just the
A 200 amp circuit breaker.
Yeah, or maybe it's a one. It's a 140 amp.
Okay.
Let's disconnect. What's back there? We may need to.
Oh, something happened. Just for a second. I think he might have just moved a little. Oh, man.
We need a screw. We need like a Phillips, and then pop this guy out. Pop that guy out.
Oh, you don't need a Phillips. You got an Alex and a Daniel and a Noah and a you don't need a Phillips. And then you got just your unique names, the Winter and the Giovanni's.
Reset. Okay.
Felipe.
Loosen.
Felipe. It's like the Casanova of the crew there.
The Casanova.
I just seeing who's paying attention.
Now, I don't know if these fucking things are hot. Ground battery power. Huh? Let's disconnect it. What's this doing?
Oh. So Nico, I got a question. Are you the one working on this thing right now?
I am Alex's.
Alex was working on it? Okay, good.
No, I'm working on
Well, actually, yeah, Nico is mostly.
Actually,
I'm the assistant hands here.
Oh, this is a fail. Alex?
Yeah.
Okay, you need to hand the microphone to Nico, and then you need to take the tools out of his hands.
okay.
See, this is like a Mark Twain lunch and learn, where your entire crew has Tom Sawyered you into working on these cars.
Well, so right now I disconnected the 3 wires. I pushed the reset button on on this aftermarket thing. That allegedly opened up the circuit. We could check that with a voltmeter. Hey, Noel, why
Yeah.
don't you come over here and check this with a voltmeter real quick?
There you go.
Make sure that it's open. And then there was 3 wires coming in. Check that output right there.
What is
On
this?
what's
Let me see
that
something.
to ground? It should be 0 volts right now. What's it at? Zero.
0.01.
Okay, and then and then what is it now? 13. Okay, so we'll just leave it open.
Yeah, so there's 1.1.2, 1.3. That's, it's over a volt of peak to peak. So half a volt of induced noise throughout the entire electrical system. That has to be. I mean, that I can't say that that's the root cause of the problem, but it sure doesn't seem like it would help, right? Especially
Yeah,
if
like
we're
it
looking
shouldn't
at
be like that.
plausibility.
So what's the net? Should we like disconnect the alternator or something?
The alternator isn't going to be doing this because it's not running, right?
Yeah, it's not running.
But look, I mean, we've got these little humps in here. So what is this? Is this a motor? Are these why does it keep starting? There's like I'm just trying to think what else. So now we're looking at the whole car, right? And we're not just looking at the engine. Like, what do we have that would do this? Fuel pump. But that's kind of a weird fuel pump. Is fuel pump running right now? Can you hear it?
It's open.
That's odd. So we just tested the power. We just tested the power on that big ass. Were you looking at what side are you looking at? But it's going to the battery, right? That's going to the battery, and that's going out. And then if you push the button, what does it have now?
It's the same.
Yeah, interesting. Well, so this this aftermarket thing stopped working. It's always powering it now.
Cool.
It's not going open when I push the button.
That's the Never Fail brand circuit breaker. Always on. Never opens.
Well, it did just open,
And then now it's closed.
but now it's not going open. And the shit's old. It's old stuff. It's not like it's old stuff. It's like a system put back in 1999.
Oh man, partying like it's 1999. Be careful of what you might find back there.
Yeah. It looks, I mean, it's the car's clean. But man, something's funky.
That's weird.
Yes, this is just I mean, it's a little bit of a, I don't want to, it's enough of a disturbance that it warrants investigation, but is that the root cause of our problem?
Yeah, because usually they don't have like those big giant sweeps on there like that.
Yeah, and I mean, we're talking, on the DC side of this, it would be about a half a volt of disruption happening at a pretty frequent interval. What is the interval here? It's let's just open this back up a little bit. Oh shoot!
Let's get a tool that disconnect that wire.
All right.
Let me get back out of here.
It's gonna be American shit.
American shit.
Like smaller than 9/16. Yeah.
Oh geez. What happened? geez, what happened? All right, now let's let me grab some cursors. Not gonna let me use it. Not gonna let me get cursors.
Oh yeah.
No, I don't want face rulers. I want graph rulers. On. Where's my graph rulers? These guys. Here we go. All right, I'm gonna go.
Check the voltage.
Get out of here.
Not.
Get out of here. All right, now.
Where's that going?
Oh wait.
No. Where's that going?
It's not going to the battery. I'll tell you that.
Interesting.
What the hell is going on?
Oh, has he got some kind of he's got one of those free electron, he's capturing free electrons?
Yeah, but look, it goes right up there. It
You
goes right
Tesla?
up.
That fuse.
So that is coming from the front. Is there a big red wire coming up to the front here somewhere? Off of this post somewhere?
No, that's factory.
That's factory.
Wait, what about below? You see?
Mhm.
No, it's not factory.
So then where's that getting its power from? Make sure that's not that's not going to get grounded out.
One
Okay.
millisecond. So 3 milliseconds.
We'll find the
Yeah,
source
so-
of the power is coming from.
It's every 1 millisecond. So it's like 9. It's about 9 pulses of every 1 millisecond in bursts of about a half an amp above the supply voltage, and then a half amp or amp, but half a volt above the supply voltage line, and then a half a volt below. So total amplitude of about a volt every 1 millisecond. So what? That's just so.
Every
And-
1 millisecond or every
Yeah, so if you move this, it's about a millisecond, right? So here's a millisecond. Come over here. There's a millisecond. Well, 1.2. If I go over there, that's 2. Over here, that's 3, right? Mouse is sucking ass today. Right there. It's about 3 milliseconds. So let's just call it a millisecond. Why not? What's a couple microseconds between friends?
All
But
right,
yeah,
so it's almost 2 o'clock here. So our homework, we're gonna try to figure out how to make that go away, and then
Well, let's just be clear here. What do you guys think? Do you think that this could be related to the fault, or is this a red herring? Do you think that this is worth investigating based on the throttle potentiometer fault and the coil fault?
yes or no?
How many say yes? Raise your hand. How many say no? Raise your hand. How many didn't want to raise your hand? Okay, good. That guy right back there. Good, dude. You don't have to get involved. All right. Okay. So it looks like we're going to investigate it. But where I was going with before I started looking at that is that I'd like to pull the DME out and measure the grounds. So ground to chassis ground. Do a voltage drop to the engine and to the chassis ground on the grounds when the engine's running, and just see if we don't have a voltage drop on the ground side. Because some of this could actually be that, but this induced voltage from the body side is kind of an interesting deal that very well could be in play. So if I was going to weight the two, I would say I would weight the DME grounds a little heavier than the induced voltage, but I think that's a close second, just to clear that out. So obviously we want to present that to the advisor so they can sell some time for that. And then on our diesel, wrapping up here, that freeze frame data was set at no RPM, with no speed and at 100% load. In our current data, if we go and look at live data, right, we're not. What's our current load? It's probably like 15% or something like that. At no RPM. So I'm a little dubious of this fault. I don't know that it actually. I mean, it happened more than once, right? Because it did set a fault, but I'm just wondering about the quality of that sensor. And you know, if you're gonna on the next, I would definitely record this, and on the next road test, I would look at this live data and I'd plot it, focusing on calculated load and the intake air pressure and temperature. You might want to look at the. I definitely want to look at the inputs. Your 5 volts. Make sure you have the 5 volts, and if you do have it hooked up, you might as well use a voltmeter and do a min max and leave it on when you go for your road test to see if you get a dropout in that 5 volt signal, using the power, the 5 volt in and the ground for the sensor as your test points. So that's what I would recommend on the diesel. Again, so that's your plan, and you would present that to your advisor, and they could make sure to sell additional time for that.
Okay, so then the back on the M3 real quick. When you say DME grounds, are you just talking about the individual grounds that are going into the DME, all the different ones?
Yeah, I think there's probably going to be about five or six.
Okay.
Right, and so those grounds are for you know, the function of drivers, you know, driving high voltage components, and then you'll have grounds that are going to be used for sensor grounds, which will have they'll have a resistor in line, and they'll be obviously elevated because of that, right? But if we have a bad ground going, you know, into the DME or you know, supplying the DME with ground, then that's going to shift or even make implausible some of the values that is expected, right? Just something in my gut says that, you know, I'd like to know that the grounds to the DME are while it's running are in good condition. We have less than 100 millivolts of voltage drop from the pin to engine ground or to the battery ground, actually, if you want to go so far as to do that. When the engine is running, though, the alternator case is the most ground on the vehicle.
Okay.
For what that's worth.
Alrighty. Well, thank you, Eric. We got some stuff to do.
Okay. And then hey, one more question. Who's working on the M3? Is it Alex?
Alex.
Alex, hey, did you do courtesy inspection on that?
Yes.
Okay. Yeah. And then Noah, did you do a courtesy inspection on diesel?
No.
Okay, come on, buddy.
I know.
All right, do that, then turn in your recommendation to your advisor.
Thank you, Eric.
All right, talk to you later.